the jejunum. All right, the jejunum, much longer than the duodenum. You don't have a slide for the jejunum, so I don't usually ask you to identify anything about it on the lab final exam. It is kind of that intermediate kind of middle section, if you will, of the small intestine. Very large structures, and these structures, they're visible here, although they're not quite as pronounced as they are, for example, in the jejunum. Right? These finger-like structures are called intestinal villi. There are lots of specializations within the small intestine that maximize surface area for absorption. Okay, because where do we complete digestion? Where does absorption of nutrients, all right, like carbohydrates, proteins, lipids occur? Yes, there's some absorption in the large intestine, but the primary organ for nutrient kind of digestion absorption is the small intestine. All right, so these are very prominent intestinal villi that increase significantly surface area to maximize absorption. All right, and then from the jejunum, we move into the ileum. This is admittedly a much lower magnification, but it really brings out, all right, it really brings out, again, those structures that are going to help you to identify, or at least, if you're shown a region of the small intestine, help you distinguish whether it's duodenum or ileum. And that is generally in the submucosa, right? The submucosa where you find these depicted, all right, in this particular section. Those structures are Peyer's patches, right? That's mucosa-associated lymphatic tissue. We just talked about that the other day in lecture, right? In our discussion of the lymphatic system. Mucosa-associated lymphatic tissue called Peyer's patches. So you find these Peyer's patches in the ileum, kind of that terminal section of the small intestine. Yes, there's intestinal villi. They tend to be much broader, all right, than they are, for example, in the jejunum. There's some changes in the characteristics of them. All right, vast majority of absorption occurs really in the duodenum and in the jejunum. All right, absorption begins to decline as you move into the ileum, and then by the time you get to the large intestine, there really isn't nutrient absorption per se. All right, there's going to be some vitamins and such that get absorbed. A little bit of water gets absorbed. But far and away, most of the absorption is going to occur prior to arrival at the ileum. Okay, so that's kind of the last, if you will, segment of the small intestine. From the small intestine, then, there is, all right, we go to the large intestine. The large intestine is also known as the colon. Also known as the colon, and there is a structure that regulates the passage from, regulates the passage from the ileum into the large intestine. The first section, if you will, of the large intestine is called the cecum. And I indicate that now because the name of that structure that regulates passage from the ileum to the cecum is called the ileocecal valve. Again, it's a sphincter. It's a circular muscle called the ileocecal valve that upon relaxation permits that tasty cake and cheesesteak, or at least what's left of it, to move from the ileum into the cecum. Ileocecal valve. Right? And then from the cecum, and again, we still got our simple pulmonary epithelium. From the cecum, we move through the ascending, almost done, transverse, descending, and sigmoid colon. Ascending, transverse, descending, sigmoid colon. I didn't want to write colon after each one of those. All right, and then from the sigmoid colon to the rectum. All right, and then from the rectum out.
What's number 3?
Right down there. No,
Transverse.
transverse. transverse. Now, that being said, it doesn't just get to the rectum and then boom, fall out. All right, there are sphincters. there are sphincters. All right, one of them is under conscious control, the other one is not. All right, what happens as that feces, right, or fecal material causes distension of the rectum or stretching of the rectum, it triggers the defecation reflex. And that defecation reflex causes relaxation of the internal anal sphincter. So there is an internal anal sphincter that is smooth muscle that is not under voluntary control. So as that rectum becomes distended, all right, and it triggers a defecation reflex, among other things that happen, the internal anal sphincter relaxes. That allows that fecal material to move down into the kind of what we call the anal canal. All right. What's preventing it from exiting the body at that point is that with, relaxation of the internal anal sphincter, you have simultaneous relaxation or contraction of the external anal sphincter. So you have simultaneous contraction of the external anal sphincter. External anal sphincter, skeletal muscle. All right? And then when the time and the place is appropriate, voluntary relaxation of the external anal sphincter allows for the elimination of that fecal matter from the body. Okay? And we'll talk, obviously, the defecation reflex is like a second to the last slide in the PowerPoint presentation. Very appropriate. All right? Kind of sets you up in the first number of slides with the background that you need, and then we basically eat a peanut butter and jelly sandwich. Talk about what happens to it all along the way. Okay?
What's the word by the arrow below 3 of the Ileum?
I don't know.
You're looking down. Oh. So where you see small intestines, under number 3.
Oh, small intestine under number 3?
Yeah, what does that arrow?
That's a down arrow.
But what's next to it?
Oh, next to it. Ileocecal. I-L-E-O. I-L-E-O-C-E-C-A-L. Valve. V-A-L-V-E. C-E-K-A-L.
Okay.
So the mucosa of the large intestine, at this point, a lot of water has already been absorbed. Most of the water is absorbed in the small intestine, and nutrients are absorbed. So that's where most water gets absorbed, is along the small intestine. There is additional absorption of water, but certainly the material, by the time it arrives in the large intestine, is going to be more dry. So you tend to find lots of mucus glands, right? Lots of goblet cells in this case associated with the colon to help reduce friction, right, as that material moves the length of the large intestine towards the exit. We're not going to talk about the pancreas and gallbladder. We'll talk about these organs a little bit more later. All right, not now. Okay? But anyway, all right? So that's the general path that it's going to take. And again, remember, simple columnar pretty much all the way down till the very end here, where we go back to a stratified squamous, essentially, kind of toward the end of the anal canal.